So this is the unit 4.3, and it's going to be talking about monotonic. So what is monotonic? Monotonic, we say that if the function is monotonic on AB, if the slope is either increasing or decreasing on AB. So let the function be differentiable function on an open interval between A and B. So if the derivative of this is positive, then f is increasing on AB. But if the derivative of x is negative, then f is decreasing. So essentially, between these points, we can see that the derivative of this thing kind of shows if the slope is positive. So if our derivative is positive, then we know the slope is positive. And if the derivative is negative, we know that our slope is going to be negative. And we can use this to find the shape of our function. And we can also use it to find if our critical points, so these lines right here, are minimums or maximums. So below, here's an example. I'm going to use number 27 from the book, and it essentially is y is equal to 3x to the power 4 plus 8x to the power 3 minus 6x squared minus 24x. So the first thing you would do is you would find the derivative of this. So we find our derivative function, which is going to be equal to 12x cubed plus 24x squared minus 12x minus 24. So once we've found that our function, we can try to find our critical points. So essentially our derivative here, if our derivative is 0, so right across there, then we know that's our critical point. So we're going to make this 0. 12x cubed plus 24x squared minus 12x minus 24. And from there, we can essentially split these into two. And I pulled out my 12. So I got 12x squared bracket x plus 2. And then we minus 12 and x squared minus 1. And then so after that, I then pulled out another 12. So I got 12, which is going to be equal to x plus 2 x squared minus 1. And after that, we can see that our critical points are going to be essentially x plus 2, which is going to be equal to negative 2, x plus 1, which is going to be equal to negative 1, and x minus 1, which is going to be equal to positive 1. So after you find the critical points of your function, you can then put them into this graph and essentially figure out if your critical points are minimums or maximums. So the first one, we find our interval from infinity to negative 2, and I use negative 3, and in my derivative I got a negative number. So that means that our slope is then going to be negative. A negative 2 is 0, and for a negative 2 is equal between negative 1, I used negative 1.5, and from that number I got a positive. So essentially, because our graph, so at negative 2, essentially our graph is going to go down and come back up at negative 2, and our next point is negative 1, and at negative 1 we can tell it's a max because we're going from positive to negative. And between -1 and 1, I use 0, and I got a negative number. So essentially, we're going to come back like that. And at 1, we know it's a minimum because we got a negative from here, and from 1 to infinity, I use +2 here, and I got a positive number. So we know that at 1, we're having another minimum. And we know that our equation is a quadratic, or sorry, it's to the degree of 4. So that means that we're going to have 1, 2, 3, 4, and it's going to end up at the top.